Welcome to training on OISD-106, Pressure Relief and Disposal Systems. Prepared for Safety and Operations Team by Yash Rathore, Source Oil Industry Safety Directorate. Objective: to ensure safe working practices in oil and gas industry by preventing equipment overpressure and ensure safe gas disposal. Introduction and scope. Purpose: to prevent equipment overpressure and ensure safe gas disposal. Based on API 520 and API 521 adapted for Indian conditions. Applies to refineries, petrochemicals, oil and gas facilities. Covers pressure greater than 1 kg per square centimeter, excludes transport vessels. Key definitions. Relief valve, opens on overpressure and recloses automatically. Safety valve, pop action valve for gas, vapor service. Rupture disc, non-reclosing device that bursts at set pressure. Set pressure, point where relief device opens. MAWP, maximum allowable working pressure operations. Need for relief system. Protects against equipment rupture and fire exposure. Controls thermal expansion and pressure surge in pipelines. Provides emergency depressurization capability occur. Types of pressure relieving devices. Reclosing type, spring-loaded, balanced, or pilot-operated. Non-reclosing type, rupture disc, pin-actuated. Surge relief valve, for liquid pipeline pressure spikes, and emergency depressurizing valve. Setting and installation guidelines. Set pressure equals 110% of operating pressure, typical. Inlet pressure drop is less than or equal to 3% of set pressure. Mount valves on top of vessels, short inlet line. Provide free draining and no pocket formation. Multiple and spare valves. Used when single valve cannot handle full capacity. Staggered set points, MAWP and 105% or 121%, fire case. Spare valves allowed for maintenance with isolation interlock. Disposal systems overview. Two types, atmospheric and closed, flare system. Atmospheric discharge only for non-toxic, non-flammable vapors. Closed system includes header, KOD, seal drum, flare stack. Only qualified personnel allowed. Closed disposal system design. Header slope, 1:500 toward KOD. Pressure drop is less than or equal to 10% of valve set pressure. Knockout drum, 20 to 30 seconds residence time, demister pad. Seal drum, prevents flashback, 600 to 1200 mm water seal. Purge system, prevent air ingress. Flare stack design and radiation limits. Stack height ensures safe radiation levels, -6.3 kW per square meter, short exposure, personnel. -1.26 kW per square meter, boundary limit. Flare tip, stable, smokeless, corrosion resistant. Pilot burners, is greater than or equal to 2 with auto ignition and monitoring. Ground and sub-flare systems. Ground flare, enclosed or open type, is greater than or equal to 98% combustion efficiency. Multi-point burners reduce noise, less than 85 decibels, A. Sub-flare, independent small flare for unit level venting. Layout and location criteria, is greater than or equal to 90 meters from process units, is greater than or equal to 60 meters from tanks, is greater than or equal to 150 meters from control room. Flare located downwind of operating areas. Multiple flares spaced is greater than or equal to 1 stack height apart. Operation and maintenance. Continuous purge and pilot flame mandatory. Daily checks, pilot flame, purge flow, seal level. Annual inspection, KOD, seal drum, instrumentation. Replace flare tip every 3 to 5 years. Environmental and safety controls. Smokeless burning using steam or air assist. Noise is less than or equal to 85 decibels, at boundary. Gas and flame detectors around flare. Lightning protection and restricted access zone. Documentation and audit. Maintain design datasheets, drawings, calibration records. Operating log, pilot, purge, seal level, alarms. Internal audit every 2 years, third party every 5 years. Annexures summary. Annexure 1. Typical flare system layout schematic. Annexure 2. Sample calculations for chord, radiation, header sizing. Annexure 3. HIPPS, High Integrity Pressure Protection System, Overview. Conclusion. OISD-106 ensures safe design and operation of pressure relief and disposal systems. Key principles. 1. Prevent overpressure. 2. Ensure safe vapor disposal. 3. Maintain reliable flare operation. 4. protect personnel, property, and environment. Thank you for watching. Like and subscribe for more.